What we are doing today is going over the results of your dice that you rolled. This is not in the packet. You will want to take notes on this because it comes up over and over again this entire chapter. This is one of the concepts that you absolutely must understand. So you can see that we're going to fill in a chart here. What I want to talk about before we get to that is if I roll a single die, how many ways can that single die be rolled? Yeah. Like I can roll that die and either a 1 or a 2 or a 3 or a 4 or a 5 or a 6 is going to come up and there's no other options. Right? So there's only 6 outcomes that can happen if I roll that single die. But if I roll another die, how many ways can that die be rolled? Some other die. 6 ways again. Okay, so I got 2 dice. Each one of them can only be rolled 6 ways each. Correct? Okay.
Correct.
Now, each die is its own thing. So when I roll 2 dice, even though I'm rolling them at exactly the same time, they are completely independent of each other. One die does not care at all what the other die does. If the first die comes up as a 3, it's not like the other die is going to say, oh, well, you're a 3, that means I got to be something else. It can still be whatever it wants to be. Okay, and that's when we rolled all those dice. That's why I said that we had 2 different colors of dice so that we could keep track of which die was coming up what. Okay? So what are the possible outcomes for rolling 2 dice? What sums can I get? 2 to 12. Why not 1? Because there's 2 dice, and the smallest number that can come up on either of those dice is 1. And if I'm adding 1 plus 1, I can't ever get an answer of 1. Snake eyes, yeah. So the lowest number I can get when I roll 2 dice is 2. The highest number I can get when I roll 2 dice is 12. And I can get any number in between. So that's why over here we have a sum from 2 to 12. Well, how many ways can I roll a 2? How can I roll a 2? Snake eyes, 1 and 1. Both dice have to come up as 1s in order for me to get 2, and there's no other way for me to get a 2. Great. How many ways can I roll a 3? 2? That's right. A 2 and a 1 and a 1 and a 2. And I'm going to write it like this. If I roll a 1 on one die, on my red die, and a 2 on my white die, then I get a total of 3. But if I roll a 2 on my red die and a 1 on my white die, that also gives me a total of 3. And you need to understand that those are 2 completely different rolls. One die came up a 1 and the other came up a 2. The other roll, the first die came up a 2 this time and the other one came up a 1. So those are 2 totally different rolls. What about for 4? What? 2 and 2 is one of them. 1 and 3, 2 and 2, 3 and 1. Yeah. Can I get 2 and 2 twice? In order for 4 to come up with 2's involved, both dice have to be a 2, right? So that is just going to happen once. So I have 1, 3, 2, 2, and 3, 1. How about 5s? I'm going to go on a limb and say 1 and 4, and then 2 and 3, and then 3 and 2, 4 and 1. Notice how I'm putting those in a logical order so that I know that I'm not doubling them up as I go. 1 and 4, 2 and 3, 3 and 2, 4 and 1. All of those give you a total of 5. How about 6? 1 and 5. 2 and 4. 3 and 3. Yep. And that's it. How about 7? 1 and 6, good. 2 and 5. 3 and 4. 4 and 3. 5 and 2. I'm just trying to stick with that logical order that I'm writing these in. How about 8? 2 and 6. Yep. Very good. How about 9s? So what do we have for 9? 3 and 6. 4 and 5. 5 and 4. 6 and 3. Is that it? Okay, how about 10? 4 and 6. 5 and 5. 6 and 4. Is that it? Yes. How about 11? 5 and 6. And 6 and 5. And 12 are boxcars. We call them snake eyes, the boxcars. 6 and 6, and that's it. So that is all the ways that you can roll 2 dice. You will always get a sum between 2 and 12, but your rolls will only come up in those ways right there. Those are all the possible ways to roll 2 dice. How many ways are we looking at? How many are there up there? Well, how many? It's not 35. It's 36. There are 36 ways to roll 2 dice. And they have to come up in one of those 36 ways. So now this is how you get probability. The fundamental counting principle, first of all. This is something that we'll talk about when we actually get into section 1, but it's worth talking about now because you actually have learned it. How many ways are there for 1 die to be rolled? 6. How many ways are there for a second die to be rolled? 6. How many ways are there for 2 dice to be rolled together? 36. How could I come up with 36? 6 times 6. The fundamental counting principle says you can multiply the number of ways for each individual thing to get the total number of ways that those things can occur together. And like I said, we'll get into that in section 1. So you'll want to write that down. To calculate probability, we're going to call that wins divided by ways. Wins are things that give you the desired outcome. Like if I want to roll a 5, how many wins do I have? There's 4. 1, 2, 3, 4. That would give me a win. Like if my life depended on me rolling a 5, there would be 4 ways for me to get a win. In other words, 4 ways for me to continue living. Out of how many ways possible can those 2 dice be rolled? Well, that was 36. It always is 36. Wins over ways calculates your probability. So how many wins do I have if I roll a 2? If I roll a 2 for a sum? 1. There's only one way I can roll a 2. Out of how many ways total? 36. So 1/36 or 1 over 36 is my probability for rolling snake eyes. A 1 and a 1. What that means is if I roll the dice 36 times, I should see snake eyes exactly once. take a look at your threes. Count up the number of times you got a 3. Four. Twice. How many times did you get a 3? A sum of 3. 3 times. 4 times? 2 times. 2 times. So we're expecting kind of low numbers, right? Take a roll of 3. Well, let's figure out what the probability is. How many ways can we get a 3? 2. That's our wins. So it's 2 over, how many ways can we roll 2 dice? 36. 2 over 36 reduces down to 1/18th. But more importantly, you guys rolled your dice 36 times. You should only see 3s come up twice. Okay? So this reduces down to 1/18th. So go ahead and calculate the probabilities for the remainder of these numbers here, doing wins over ways. What do we wind up with for a probability for if I roll a 4? There's 3 wins divided by 36 ways. So 3 over 36 reduces down to 1/12. If you were to count up the 4s that you got total, you should see about 3, a class average probably of about 3. How many, or what's the probability for 5? 5 out of 36, and that does not reduce. So we could expect to see the number 5 come up as a total about 5 times on your data. If we take a look at 6, oh, sorry, 4. Yeah, you guys jumped ahead for me. This one is 5 out of 36. So we should see a 6 come up 5 out of 36 times. This one was actually 4 out of 36, which reduces down to 1/9, which means 1 out of every 9 rolls is going to be a 5. How about 7? Yeah, 6 out of 36, which reduces down to 1 out of 6. And then 8? 5 out of 36, 5/36. And then 9? 4/36, which is 1/9. And then 10? 1/12. And 1/18. And 1/36. These are the probabilities for dice. The more you roll dice, as long as you're dealing with fair dice, the more you roll dice, the more you will see this situation come up. So I'd like to go through a few more of these numbers. Let's count up the number of each of these numbers that you have on your data. So just make a table like this and record for each 2, 3, 4, 5, 6. Just put a little tick mark or something. Use your partner and count up the number of times you saw each of those sums come up. And we'll compare them to the probability, the theoretical probability. What I want to do now is apply that probability chart that we just came up with for dice to a game that you guys know called Monopoly. You've all played Monopoly before, right? What? You serious? One, two, three, four, 5. 1, 2, 3, 4, 5. Okay, so here's a street in Monopoly. This would be like free parking. And then we have 1, 2, 3, 4. Here's a railroad. 1, 2, 3, 4. And then this would be go to jail. Not Jim Tan jail. It's go to jail. So let's say that you are the top hat, because you always play the top hat, or at least I always play the top hat, and the shoe and the wheelbarrow, so you can wheel around all your money. And let's say you own these properties right here. What would these properties be? There's a railroad right here. If this is free parking and this is Jim Tan jail, boardwalk's down here. Jail's over here. Go's over here. This would be Atlantic. This would be Ventnor. And this is Marvin Gardens.
And then that would be like a utility.
This is, which one?
Montana Silver.
Waterworks.
I don't know what it is.
No, I don't. What color are these properties right here?
Purple.
No,
Red.
no,
Green.
no, yellow.
Gray.
They're yellow.
They're purple and rhodiola.
Now let's say you own all three of these properties right here. And let's say that your opponent in the top hat is sitting right here on free parking. And let's say that you have 7 houses. How do you have to distribute your houses on your properties?
Whoa.
Put them on the
Can't you
7
buy?
points.
Can I put all 7 on one of these?
No.
How do I have to distribute the houses?
You only have 5 houses on one property.
I can't have 5 houses on one property and 2 houses on another. How do I have to distribute them?
Equally.
I have to distribute them equally. So if I have 7 houses, that means I must have 2 on each one for a total of 6. And then I have 1 extra. The question is, where should I put that extra?
On the
On the second one.
On Ventnor. Why?
Those Carmen rolls a 7, so they roll like a 9.
That's right. You should put it here. Even though Marvin Gardens is more expensive, and if you hit Marvin Gardens, you're going to pay a heck of a lot more money if that third house is on Marvin than anywhere else. Despite that, because of the fact that you're most likely to roll a 7, you want to put that third house here to maximize your expected profit from your opponent's roll. This is called game theory. And that's what you're learning in this chapter. So this is the correct answer right here. Let's say now that this top hat actually, on his or her turn, rolled a 4. And now they're sitting here. A little known rule in Monopoly is that you can redistribute your houses as long as they remain basically equal. Which means that on my next turn, I can take this house and move it if I want to. As long as I keep all else equal, I can take this extra house and move it anywhere I want. So in this case now, with the top hat over here on Illinois Avenue, what should I do? That's right. Move it over to Marvin Gardens because 1, 2, 3, 4, 5, they have a higher likelihood of rolling a 5 than they do of rolling a 2 or a 3. So you would move that extra house over here. That is how you win Monopoly.
And then they roll a 3 and you feel like it's on.
Well, sure, they could roll a 3, but more likely they're to roll a 5, right? Actually, in all likelihood, they're going to roll a 6 or a 7 or an 8 and just blow right on past your properties. But you're doing the best you can mathematically to maximize your profit based on the situation that you're in. Most people don't know that that's a rule in Monopoly. You can redistribute your houses.
And that's they have.
The other thing that we can talk about now that we understand probabilities of dice is,
Craps.
yes, the game of craps. I'm not going to teach you how to play it. We're not going to play it. We're not going to place bets. I just want to show you a couple of things that are on this table that you should have a good understanding of and be very skeptical of at this point. So what we have on this table is a bunch of different, basically, bets that you can make. So you can place a bet pretty much anywhere on this table, and then if a certain thing happens when you roll 2 dice, then you either lose that money or you win some money, okay? So like the pass line, the don't pass bar, any one of these regions here, all of these numbers here is called the field, and you can place bets on any one of these numbers coming up. If you happen to get a 2 or a 12, you would get double what you normally would get. You can make bets on these numbers here as well. You can bet against the person who's rolling dice. And by the way, this game is the game that most people are playing when you see people in a casino, like in a movie or on a TV show, and they're all gathered, they're all huddled around a big table, and then somebody's throwing dice, and then everybody yells. That's that game, okay? That's what this is. It's a very confusing game to understand. I'm definitely not trying to teach it to you. I just want to show you a couple things on here. What I want to show you is this region right here. Like I said, you can bet anywhere on the table. I want to look at this region here. they're showing you, see these colons here? 4:1, 7:1, 15:1. They're showing you the payout, the odds, basically, or the payout that you're going to get. So like if I were to put $1 on this square right here, what I'm saying is that the next roll is going to be 2 5s. Okay? And if it is, they will pay me 7 times the amount that I put down. They'll give me $7 for every $1 that I bet. Does that make sense? You understand that? Okay. For a 2 and a 1, exactly. They'll pay me $15 for every $1 that I bet. For exactly 6s, they'll pay me $30 for every $1 that I bet. Does anybody see anything wrong with that?
Yeah, they're all
They're off by a lot. Yeah.
no, like, since we rolled like 36 times, how you get one.
How many, what is the probability of rolling 2 6s? 1 out of 36. So that means that if I roll the dice 36 times, I should see 12 exactly once, right? Which means that there were 35 times that I did not get a 12 to 1 time that I did get a 12. Which means this right here should actually be 35 to 1. These are the odds. This is what it should pay. But they don't pay. They pay 30 to 1. Why?
That's how they make money.
That's how the casino makes money. They fiddle with the odds to make them in their favor, not your favor. Okay? In a casino, the odds are ever in the casino's favor. There is no way to beat the casino. This way, even if somebody wins huge on a bet right here, like if I put $10 down here and somebody rolls a 12, right then and there, I get $300 plus my $10 that I put down for a total of $310. I won big. But over time, people will continue to bet there and they will continue to lose. And even though they continue to lose and somebody won big, they're only giving you 30 to 1 instead of 35 to 1. Which means that over time, even though one day they might lose money, over time they will make money. In fact, they're going to make $5 every single time, basically, somebody puts a thing down there. This is where the casino makes their money. On sucker bets like this.
Is every casino fast table?
No, this is a standard table. Okay? Now, it gets even worse. How many ways can I roll an 11? There's 2 ways to roll an 11, right? It reduces down to 1 over 18, which means for every 18 rolls that I roll, 1 time I should see an 11, which means 17 times I won't see an 11. They're only paying 15 to 1 here. So there's another $2 that they're not giving you. Okay? What about here? It's the same thing as the 11. 15 to 1, it should be 17 to 1. What about here? How many ways can I roll 2 5s? There's only one way to roll 2 5s, which means if I roll 2 dice, what's the probability of me rolling exactly 2 5s? 1 in 36, which means it should have the same exact payout as 2 6s. But it doesn't. They're only going to give me 7 to 1 on that. They should be giving me 35 to 1. It's because of the numbers on the dice. That's right. People play this game and they think, oh man, I got a better shot at getting 2 2s than I do at 2 3s. Do I have a better shot at getting 2 2s than 2 3s? No, it's the same probability. It's the exact same probability as 2 6s or as snake eyes. But they're only giving me 7 to 1. They're only going to give me $7 for every $1 that I bet here compared to $30 for every $1 that I bet here. It's a joke. This whole thing right here is a giant sucker bet. I do. I laugh. Because if you watch people bet in here, sure they win every now and then. But most of the time they lose. And even when they win, they don't win what they should win. And that is where the casinos make money. Because they don't pay you what you deserve. That's where they make their money. They make billions of dollars every single year. And even though people walk away with millions, they still make billions more because of bets like this. And there's bets like this all over this table. the best you can do is slow down the amount of time it takes you to lose all of the money that you have in front of you by avoiding things like this. But otherwise, there's other bets on here that are just as bad. Easily just as bad.